Hey everyone, welcome back to another video by Cam Room 5. Today's video is going to be about the periodic table of elements. Periodic table is an arrangement based on atomic number. It has groups which are vertical. The groups are vertical columns from the left towards the right. You can see group numbers highlighted with separate arrows here. Group number 3 is with a blue. Then group number 4, which starts with carbon. Group 5 starts with nitrogen. Group 6 that starts with oxygen. Group 7, which are called halogens. And then group 0, which is also group 8, and they're called the noble gases. The group number will tell you the number of electrons in the last shell. It tells you the electrons in the valence shell. Then comes the periods. The periods are horizontal rows. These are like arranged from left towards the right. You can see hydrogen and helium are the only two elements in the first period. Then period 2 starts with lithium, period 3 starts with sodium, and period 4 starts with potassium. When you notice, the group number will always tell you electrons in the valence shell or the outer shell of the atomic structure. And the period number will tell you the number of shells, the total number of shells of electrons in that atomic structure. Let's take an example. Let's pick boron, which has the atomic number of 5. It belongs to group number 3, and when you count, it's period number 2, group number 3 and period number 2. So technically boron should have 3 electrons in the last shell because group number is 3, and boron should have 2 shells because period number 2. I'm drawing the nucleus here. The nucleus has the neutrons and the protons. So the nucleus has all the nucleons. And then when you draw the number of electronic shells, it should have 2 shells because boron is period number 2. When you start filling the electrons, you will realize that the last shell should have 3 electrons because boron belongs to group number 3. So there are 3 electrons in the last shell. And then obviously the first shell always has 2 electrons. So as a result, you can see first shell has 2 electrons because first shell has a capacity of 2, and second shell has 3 electrons because group number 3. So the electronic configuration, when you write the electronic configuration, you will write 2, 3. 2 electrons in the first shell and 3 electrons in the second shell, which is by the way the last shell. Now let's take potassium as an example, which belongs to group number 1 and period number 4. By the way, notice potassium has 19 protons. So when you draw the nucleus of potassium, it will definitely have 19 protons, and obviously the neutrons also should be here. So the nucleus contains 19 protons, and then obviously it has, by the way, 20 neutrons. So atomic mass as atomic number will tell you how much neutrons and protons are here. It is period number 4, so you should draw 4 electronic shells one after the other. The first shell, second shell, and the third shell are also called the inner shells. The last shell should have 1 electron because potassium is in group number 1, so last shell has 1 electron. First shell, second shell, third shell, and now you can see the fourth electronic shell. Last shell has 1 electron because group number 1, but the inner shells are complete. So you don't have to worry about the inner shells. I am completely drawing inner shells. 2 electrons in the first shell, 8 electrons in the second shell, then again 8 electrons in the third shell, and fourth shell is like it has 1 electron because group number 1. When you try to write the electronic configuration, you will have 4 numbers, one number for each shell's electrons. 2, 8, 8, 1. This is the configuration about potassium atom. And when you total it, it has 19 electrons, which is also equal to 19 protons. Remember, atoms have equal protons and electrons. Now, another thing about the periodic table is that from group number 1 till group number 3, including the transition elements, that big block in the periodic table after group number 2 is called transition elements. Group number 1 is called alkali metals because they make alkalis. And group number 2 is known as the alkaline earth metals. They are also slightly basic. That is why we call them the alkaline earth metals. So group number 1, 2, and 3, including the transition elements, are metals. And from group number 4 till like group number 0, you have non-metals. Let's have a look at the structure of metals and non-metals. Let's pick sodium as an example of metals and chlorine as an example of non-metals. Sodium atom has its nucleus, and since sodium is period number 3, sodium has 3 electronic shells. The electronic configuration of sodium should be 2 in the first shell, 8 in the second shell, and then since sodium is group number 1, so obviously we know there has to be 1 electron in the outermost shell because that is how group number 1 elements behave. Sodium, like all the metals, they lose their outer shell electrons, so lose valence shell electrons. Sodium atom will lose its valence shell electrons and form cation. A cation means a positive ion. But when sodium loses the electron keeps on revolving around the sodium cation. So sodium makes a positive ion and the electron keeps on revolving around it. So all the sodium make cations and there are electrons around it. So you can notice there are so many sodium cations which have positive charges on them. Each sodium cation has a positive charge on it because it lost its valence electron. And where's the valence electron? It is making a sea of electron, which is common to all the cations. We call it a lattice of cations. Lattice means a regular arrangement. So since sodium cations make a regular kind of arrangement, we call it a lattice of cations, and the electrons keep on revolving around this entire lattice. Like jokingly, it seems like a communism kind of thing where the electrons are shared by all the cations together. This is the idea of a metallic lattice, where you have a metallic lattice has lattice of cations. Lattice means a regular structure and a sea of electron. And positive and negative attract each other through electrostatic attractions. So the attraction in the lattice is the electrostatic attraction. These electrostatic attractions are really strong, and that is why metallic lattices are really, really hard. Stronger metallic lattices have stronger attractions. Now starting chlorine atoms have their nucleus, and chlorine belongs to period number 3, so there are 3 shells. 2 electrons in the first shell, 8 electrons in the second shell, which is a completely filled shell, and 7 electrons in the last shell because chlorine belongs to group number 7. And all the elements in group 7 have, last shell has 7 electrons. Two chlorine atoms combine to make a diatomic molecule. They don't have a lattice kind of structure, they make diatomic simple molecule. They exist in pairs. You will never see a chlorine atom alone by itself. Chlorine atoms have a simple molecule with strong covalent bond. This strong covalent bond is actually because of the sharing of 2 electrons between 2 chlorine atoms. Covalent bond between 2 atoms, and it makes one molecule. Similarly, 2 other atoms will make another molecule and another atoms will make another molecule. Each pair is called a simple covalent molecule. They don't exist as a whole group of molecules, they rather have individual molecules. One molecule can attract another molecule very slightly through very weak intermolecular forces. There are very weak intermolecular forces between each other. That is why these molecules can move away from each other. So there is no metallic lattice in non-metals obviously. There are covalent molecules there. Lithium, sodium, potassium, magnesium, calcium, these are soft metals. Their metallic lattices are not very strong. The electrostatic attractions there are not very rigid. There are other metals which are called the transition metals. Their metallic lattice is very hard, like silver, copper, iron, lead and zinc. They are called transition metals. Their metallic lattice is very hard with very high electrostatic force. When you talk about non-metals always have diatomic molecules. There are some cases when there are, molecules with 3 atoms or molecules with 4 atoms. But mostly there are diatomic elements like F2, which is fluorine, Cl2, Br2, which is bromine, I2 is iodine, O2 is oxygen, N2 is nitrogen, H2 is hydrogen. They are always having diatomic molecules with weak intermolecular forces, and that is why they normally exist as gases. I hope this idea is clear to us. In the next video, we'll talk mostly about group 1 elements. Stay tuned guys. Thanks.